Okay, for number 3, we want to give a parametric equation that describes a full circle of radius r. So we aren't given a value for it, we just know that it is r. Centered at the origin with clockwise orientation. So instead of going in the positive angle, it's going to go in the negative angle direction. Where the parameter varies over the interval 0 to 10. So what this means here is that 0 to 10 has to give, in the parameter, has to give, oops, I drew that in the wrong direction, has to give a full rotation here, right? So as we've seen previously on video number 2, a circle in our normal Cartesian equation is described by x squared plus y squared is equal to r squared. But what we can do instead is treat x and y as outputs of a parameter t, where t is considered our angle. So if we think about this, if we break this down into I'm going to break this down into a triangle, right? If we break this down into a triangle where this is r and this is t. So we want to be able to express x and y in terms of a parameter t. And we're going to treat t as an angle, and then it becomes very easy using trigonometry. Because if we remember that sine of t, sine is opposite over hypotenuse, so it's going to be the opposite is y, hypotenuse is r, and cosine of t, which is adjacent over hypotenuse, so cosine of t, x is adjacent and r is the hypotenuse. So if we multiplied both sides by r, we get the equations x is equal to r cosine t, and y is equal to sine r sine of t. Okay, so once we have these equations, we're almost there, but we're not quite done yet. The reason that we're not quite done is because if we just treat it, if we just leave it as t, two things are going to happen. One is it's going to go around in the normal positive direction, right, which is counterclockwise, and we wanted to make it go the opposite way. So that's the first thing that we need to fix. And the second is, if we just leave it as it is, it's going to complete a rotation whenever t is equal to 2 pi, because a circle completes a full revolution with 2 pi radians. So we need to adjust it so that it completes a full revolution, not in 2 pi, but in 10. And the way that we're going to do this is we're going to think about it like this. So we're going to say x is equal to r cosine of, I'm going to say kt, where k is just some constant, right? And why are we doing this? Because when I plug in 10, I need cosine to behave as though I had plugged in 2 pi. Because if I plugged in 2 pi, it's going to behave like I did a full revolution. So I want 2 pi to have the same behavior as k times t whenever t is equal to 10. So what that means is that if t is equal to 10, it means that k times 10 has to be equal to 2 pi. It has to behave as though I had plugged in 2 pi. And so if we divide it out, thus k is going to be equal to 2 pi over 10, or k is equal to pi over 5. So that's the concept of multiplication, right? So we can now improve this. We can now improve this to x is equal to r times cosine of pi over 5t, and y is equal to r sine of pi over 5t. Because you can see that if we plug in 10 here, we're going to have pi over 5 times 10, which is the same thing as 2 pi. So that guarantees that it will do a full circle whenever we reach 10. So that's a neat little trick of making the input, we force it to be equal to 2 pi, right, whenever t is equal to 10. And we're nearly done. The only thing that we have to add is a minus here, minus to the t. The reason that we have to add this is because if we don't add it, it's basically going to do this whenever t is 10. But we want it to go in the opposite direction. We want it to go clockwise, right? And the only way to go clockwise is if we make it go in the negative direction. That's why we need to add a negative there. So we are done. This over here is our pair of equations that does describe this motion.